So we got a little bit of good news, bad news. The good news is this is the last section of the entire school year. The bad news is it takes more than one day, so it'll be more than one video, but we'll get this idea of the quadratic formula introduced today, and then in the second video we'll fully use the quadratic formula. There's going to be things we can take away from it today, though, and you'll see some of probably the weirdest, most difficult math you've ever seen, or at least you've ever had someone attempt to explain to you today. And don't worry, it's nothing you have to like memorize or recite or anything like that. It's just if I can show you where a formula comes from, then I'm going to do it. Again, it's pretty intense, but we'll get through it. But before I get way into section 9.9, even though the section 9.8 homework is not due yet, most of you have done it, and I looked at it, and I think we need to go over it. So I want to do those 5 questions first. And this completing the square is pretty difficult under normal circumstances, and we're far from normal circumstances right now. So I'm going to give you guys a chance to see me work them out, and then look over your own work and see if you can find mistakes. So here we go. Number 1, all right, we want to solve this by completing the square. So remember, the first thing you're going to do is take that constant and move it to the other side. So I'll have x squared plus 6x equals negative 6. I think this marker's going out. I'm going to switch markers here. So let's identify what b is. B is 6. That came from right here. Half of b is 3. And then if we take half of b and then square it, we get 9. This is the number that completes the square. So we want to add 9 to both sides. Now I have a perfect square trinomial over here. That factors into x plus, and then that number you can get from taking half of b, which is 3 squared. And negative 6 plus 9 is 3. So now we can take the square root of both sides. This will get me x plus 3. This will just simply be plus or minus the square root of 3. And then take this plus 3 and transpose it over to the other side. And I get x equals negative 3 plus or minus the square root of 3. So there are my 2 solutions. Negative 3 plus the square root of 3 and negative 3 minus the square root of 3. All right, number 2. So again, start out by taking the constant and moving it to the other side. So I have x squared plus 12x, leave some space, equals 4. B is 12. Half of b is 6. And if I take half of b and square it, I get 36. That will complete the square. So plus 36 plus 36. This is now a perfect square trinomial since I completed the square. It's going to factor into x plus 6, the quantity squared, equals 40. Take the square root of both sides. I get x plus 6 equals plus or minus the square root of 40. Now, the square root of 40, that is the square root of 4 times the square root of 10, which is 2 square roots of 10. So I do want to simplify my radical numbers. So So that's plus or minus 2 square roots of 10. And then now I'm going to take this plus 6 and transpose it over to the other side. So I'll get negative 6 plus or minus 2 square roots of 10. So there are my two solutions. One of them is negative 6 plus 2 square roots of 10, and the other is negative 6 minus 2 square roots of 10. All right, number 3. Take that constant and move it over. So x squared minus 2x equals negative 4. Okay, b is negative 2. Half of b is negative 1. Take half of b and square it, you get positive 1. So we'll add 1 to both sides. This factors into x minus 1 squared, again just take it from there, equals negative 3. Take the square root of both sides, and right here I cannot take the square root of a negative number, so I'm done. This one is no solution. Okay, in other words, if this was to be graphed, it would look something like that. It would never cross the x-axis. All right, number 4 from the section 9.8 homework. Start out by transposing that constant over, so that's minus 10x equals 3. B is negative 10. Half of b is negative 5. Half of b squared is 25. So that'll complete the square. And then I have to add it to the other side to balance the equation. This is a perfect square trinomial, which is factors to x minus 5, the quantity squared, equals 28. Take the square root of both sides. This is just x minus 5. The square root of 28 is the square root of 4 times the square root of 7. So that's 2 square roots of 7. So that'll be plus or minus 2 square roots of 7. Transpose that over. X equals 5 plus or minus 2 square roots of 7. So one solution is 5 plus 2 square roots of 7, and the other solution is 5 minus 2 square roots of 7. So those are real numbers. Those numbers exist. All right, number 5. Arguably the most difficult one because b is an odd number. And it introduces fractions, but we can handle it. So we have x squared minus 5x transpose plus 2 over as minus 2. B is negative 5. Half of it is negative 5 halves. And then take half of b and square it. Square the top, square the bottom. And we get 25 fourths. So plus 25 fourths plus 25 fourths. This will factor into x minus, and this is still that, 5 halves squared. Negative 2 as fourths would be negative 8 fourths. Negative 8 plus 25, so this would be 17 fourths. Take the square root of both sides. This is just x minus 5 halves. Okay, remember, you take the square root of a fraction, you can break that into the square root of the numerator over the square root of the denominator. 17 doesn't simplify, but the square root of 4 is 2. So this ends up being plus or minus 17, the square root of 17 over 2. Transpose 5 halves over. So now we have 5 halves plus or minus the square root of 17 halves. And those are the same denominator, so I'm going to write those as one combined fraction. So I get 5 plus or minus the square root of 17 all over 2. So that was the solution to yesterday's homework from Tuesday. Let's get into the new material. So, yesterday I indicated that completing the square could get way more difficult if A was something other than 1, and here I have it as 2. Okay, so this is the more difficult type of problem. You won't be required to complete the square on anything like this, but it's not a waste of time to show you because the trick in order to solve this, I have to use in the next thing I'm going to do. So I want you to at least see one with numbers and how to do it because I'm getting ready to complete the square on something a little bit different here in a second that I'll tie into what I did here. Okay, so it starts out the same. You take the constant and move it over to the other side. So negative 3 goes over to the other side as plus 3. In order to complete the square, this has to be 1. So what we're going to do is factor out that 2, and I get x squared plus 6x now. And I'll complete the square on the thing inside the parentheses. So b is 6, half of b is 3, and if I square half of b, I get 9. So 9 completes the square. But I'm not going to add 9 to this side because I didn't really add 9 here. I added 2 times 9. I actually added 18. Okay? When I put the 9 inside the parentheses, I added 9 times 2, 18. So this factors into 2 times the quantity of x plus 3, the quantity squared, equals 21. And now I need to get rid of that 2, so I'm just going to divide by 2. Those will reduce. So now I have x plus 3, the quantity squared, equals 21 halves. Take the square root of both sides. Let me erase, and we'll pick up right here. This is why I wish I was still at school where I had more room. We just have limited space here. So x plus 3 squared equals 21 halves. So we'll just kind of remember where we are there. So x plus 3 squared equals 21 halves. That's where we were. Now we'll take the square root. And this is x plus 3 equals the square root of 21 over the square root of 2. And of course that's plus or minus. Now, something you don't know is that technically you cannot have a radical number in the denominator and it still be considered simplified. So we're going to do something what's called rationalize the denominator. In other words, get rid of the radical and make it a rational number. Well, the way you do that is multiply both the top and the bottom by this same radical number, the square root of 2. The square root of 2 over the square root of 2 is just 1, right? So I'm using the multiplicative identity here. You're allowed to multiply anything by 1. It doesn't change the value of it. So what this is equal to will still be the same value as this, but it'll be simplified. So the square root of 21 times the square root of 2, that's the square root of 42. And then the square root of 2 times the square root of 2 is 2. Now the square root of 42, that's 21 times 2, so that does not have any factors that are perfect squares. So we have x plus 3 equals plus or minus the square root of 42 over 2. That'll be x equals transpose negative 3 plus or minus the square root of 42 over 2. Now I like to write that as one combined number. So negative 3 is negative 6 over 2 plus or minus the square root of 42 over 2. And then this will equal x equals negative 6 plus or minus the square root of 42 all divided by 2. So I told you, they can get a lot more complicated. And think about what didn't happen that could have happened. So when I factored out 2, I got 6, which is an even number. Well, if that was 10 instead, I would have factored that out and I would have had a fraction. So imagine having to do all of that, but with fractions involved. And then the square root of 42, even though I had to do this weird thing over here, I didn't have to simplify the square root of 42. So I could have had a whole lot more steps, even in that very long problem. But there's your answer. Negative 6 plus or minus the square root of 42 all over 2. So yeah, that was a lot harder, but of the ones of that level, that was an easy one. So just kind of be thankful that we're going to learn something that will allow you to solve this much easier. But completing the square isn't a waste of time. When you get into Algebra 2, it'll be a very nice thing to have in your mathematical tool belt. So, okay. So now we're going to see what happens if we complete the square when we just have the generic standard form. So I got to reference my notes here because this is about to get weird. Okay. So the first thing we're going to do is transpose the constant over. So I have ax squared plus bx equals negative c. So far, so good. This has to be 1 in order for me to be able to complete the square. Well, it's not 1, it's a. So I have to factor that out. So I get a x squared plus, now, what do you have to multiply times a to get back to b? Well, it's actually b over a. If you multiply that back out, the a's would cancel and you'd be left with b. So I have to leave a space because we have to complete the square on this. And that equals negative c. So b is b over a. Half of b, well, that's b over 2a. Imagine taking b over a times a half. You can see we get b times 1 is b, and then a times 2 is 2a. So half of b over a is b over 2a. And then if you take that and square it, we get b squared over 4a squared. So to complete this square, I have to add b squared over 4a squared. Now, I didn't technically add that to both sides because I'd have to take this times a. Well, do you see how that would cancel this A and then one of those A's? Think back to chapter 7 when we have, that would be over 1, so you'd have 1 on top, 2 on bottom. So you'd be left with 1 on bottom. So we would actually end up adding B squared over 4A instead of 4A squared. Again, I'm multiplying this times A, and that eliminates one of those 2 A's on the bottom. So I'm only adding the 4A with the denominator here. Still B squared on top, but 4A with the denominator. Okay. So now I have A, and then this factors into X plus, just still this. That's B over 2A squared. So again, that completed the square like it always has when we have regular numbers. And then that's what goes inside the parentheses when you factor. I just did what we've been doing. I'm going to go ahead and switch the order of these. Doesn't really matter, but it'll help me out later on. Okay, now we have to divide by A to get these to cancel. Well, that means I have to divide this side by A. So, dividing by A is the same as multiplying by 1 over A. So let's take this and act as if we're distributing that. Well, do you see 1 over A times this would just put the squared back there, so I'd get B squared over 4A squared, and then here I would get C over A. So I have X plus B over 2A squared equals B squared over 4A squared minus C over A. Okay. So now it's getting kind of crazy here. I think this is the spot where my glare is. So let me take a picture of where I am so I don't mess this up. Then I'm going to erase and start back where we left off. Okay. So let me erase. We're not quite done yet. So I was here where we had X plus B over 2A, the quantity squared, equals B squared over 4A squared minus C over A. Whew. Okay. So now we have to take the square root of both sides. Not yet. Sorry, we're not going to take the square root of both sides yet. We're going to get this with a common denominator first. So the denominator here is 4A squared. The denominator here is just A. So in order to make those have the same denominator, I'm going to make this one 4A squared. So C over A times 4A over 4A. Again, that's something over itself, so that's just like multiplying by 1. But if I take A times 4A, I get 4A squared. So this term and this term will now have the same denominator. C times 4A is 4AC. Okay, so I can rewrite this as X plus B over 2A squared equals B squared minus 4A squared minus, and then I can, this and this are the same thing, 4AC over 4A squared. Told you, this gets really, really complicated, but we'll get through it. So now that these have the same denominator, I can write them as one combined fraction. Okay, So I've cleaned that up a little bit. Now I'm going to take the square root of both sides. This will just be x plus b over 2a. I can't do anything with the top. So the top is just going to be plus or minus the square root of b squared minus 4ac. But the bottom, believe it or not, is a perfect square. 4 is a perfect square. A squared is a perfect square. So that just factors to 2a. Take this term and transpose it over. So now I have negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Now we're not quite done. We have one more step to go, but I do want to kind of hit the pause button on our progress and ask you if you notice something right here. Negative b over 2a. If you recall from way back in, section maybe 9.2, maybe even 9.1, but I think 9.2, where we learned that that is the axis of symmetry. That's where that comes from. If you go back and watch that video, I just said, hey, trust me, one day I'll be able to show you where it comes from. Well, today's that day. So what we're seeing here is this gives you the axis of symmetry, and to get one solution, you would add this number, and then to get the other solution, you would start here and subtract that number. Okay, so here's your axis of symmetry. This is plus b squared minus 4ac over 2a, and then start here, and this will be minus b squared, the square root of b squared minus 4ac over 2a. That's the plus side, that's the minus side, to get you to one solution and the other solution. These are both over 2a, so we can combine it as 1, and we get negative b plus or minus the square root of b squared minus 4ac all over 2a. So, why on earth did we just do all that very confusing, crazy math? And now I see that you can't see your x equals. I had to go back and look, but I think we'll be okay. That is what is called the quadratic formula. I would say, solving equations is more important than this. I would say knowing how to graph lines is probably more important than this. But probably the third most important thing that you'll use in upper level math is this quadratic formula. You can take any quadratic equation and just substitute in the values for b, a, and c, and you get both solutions to your quadratic equation. You don't have to factor, you don't have to complete the square, nothing. Right? You have to memorize that formula. And that might seem like it's very, very difficult to do when you first look at it, but I promise that if you play along with what I have in mind, you will have that formula memorized. If we were still in class and we were taking a regular test, you would not be able to, write that down on a sheet of paper or anything. You would have to have that memorized. Okay? Not in this video, but in the next video, we're actually going to learn how to solve equations with that. We're actually going to focus more on a different part of the quadratic equation today. So let me get this pulled up here. Okay. I already pointed out that here's your axis of symmetry, negative b over 2a. But what we're going to focus more on today is this inside the square root, this b squared minus 4ac. Since that's inside the square root, that number will tell us everything we need to know about the quadratic equation. Okay, that has a special name. It's called the discriminant. So if the discriminant, as this says right here, is less than 0, then there are no solutions. There are no real solutions. When you get into Algebra 2, you'll find out that there are imaginary solutions, but we don't care about that right now. There are no solutions, and it cannot be factored. If the discriminant is equal to 0, then that tells you there's only one solution, and that in fact it can be factored. It's a perfect square trinomial. If the discriminant is greater than 0 and is a perfect square, that tells you you have two solutions and they're rational. And yes, it can be factored. So you could have solutions like -5, -2, 3/2, and 5/3, whatever, any rational number. If the discriminant is greater than 0 and not a perfect square, you do have two solutions that just happen to be irrational solutions like they were back in section 9.8. So no, it cannot be factored, but you have to either solve it by using the quadratic formula, which we will do in the next video, or you have to complete the square. I wouldn't ever complete the square again unless I said, hey, you have to complete the square. Quadratic formula is way easier. Okay, it might not seem like it at first, but I promise it's way easier. So let's practice using the discriminant and then decipher what it means. Knowing this chart, understanding this chart will be huge. So let's practice and see if we can figure out how to go back to this chart and see what we found. So I have x squared plus 5x plus 6. So that means A is 1, B is 5, and C is 6. So if we have b squared minus 4ac, that's going to be 5 squared minus 4 times 1 times 6. That's 25 minus 24, that's 1. So our discriminant is equal to 1. So if you look back at our chart, it's greater than 0, and 1 is a perfect square. So that means we have two rational solutions, and this one could be factored. Okay. Now, it factors into x plus 5, x plus 1, so your solutions are -5 and -1, which are two numbers, and they're both rational. All right, this discriminant tells us that. Okay, so we don't have to look at that and ask ourselves, well, does that factor? Does it not factor? Do I have to complete the square? Whatever. This tells you what to do. So at this point, if you were trying to solve it, you would just go ahead and factor, because this tells you, hey, I'm a perfect square, I can be factored. All right, let's look at the next one here. So A is 5, B is 4, and C is -9. So we use our discriminant, b squared minus 4ac. That's going to be 4 squared minus 4 times 5 times -9. So that's going to be 16. Negative times a positive times a negative will be a positive. 4 times 5 is 20, times 9 is 180. And that will be 196. So if you don't know whether or not that's a perfect square, take your calculator, which my messy desk / table here. Okay, take your calculator and then take the square root of 196, and we get 14. So this is a perfect square. So again, this one ends up being two solutions that are rational. So that means this can be factored. Okay, we would have to use either a slip and slide method or a guess and check or whatever, but we could factor this and then find the two solutions. Okay, on this one we have A is 9, B is -12, and C is 4. So b squared minus 4ac, it's going to be negative 12 squared minus 4 times 9 times 4. Negative 12 squared is 144. And I'm going to use the calculator to figure that out. So negative 4 times 9 times 4, that's minus 144. That's 0. 0, if you go back and look at that chart, means that this is actually a perfect square trinomial and there's only one solution. So you don't have to even do your thing where you're like, well, that's positive, that's a perfect square, blah, 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 blah. You don't have to do that anymore. This tells you it's a perfect square trinomial. Take the square root of that, take the square root of that, still that sign. That's going to factor into 3x minus 2, the quantity squared, equals 0, and then you could solve from there. Here, A is 1, B is 2, and C is 8. So B squared minus 4AC, that's going to be 2 squared minus 4 times 1 times 8. It's going to be 4 minus 32, that's negative 28. Okay, if you go back and look at that chart, it says if the discriminant is less than 0, which in this case it is, it means there's no solution. Think about where the discriminant was. It was inside of a square root. You cannot take the square root of a negative number, so this one can't be solved. Okay, I'm going to try to make one up. There's one example that didn't happen that I want to happen. So let's do 3x squared minus 2x plus 8. Let's see what happens there. Hopefully I just guessed really well. A is 3, B is negative 2, and C is 8. So b squared minus 4ac, that's negative 2 squared minus 4 times 3 times 8. That's going to be 4. Oh, no. Let's make that minus 8. Let's make that minus 8. And then we get 4 times 3 times 8. We get 96. Of course, I tried to do it and it didn't work. So let's make this 9. I forgot to make an example like this, so I'm trying to ad-lib. Let's make that 9. So we'll get different numbers here. So 4 times 3 times 9. That's plus 108. And now we get 112. Okay. If you go to your calculator and you take the square root of 112, you get 10.58300, blah, blah, blah. In other words, this is not a perfect square. So this, you would either have to complete the square or use the quadratic formula to solve. It's greater than 0, but not a perfect square. Again, I'm just going back and I'm looking at this chart here. So 112 is greater than 0, but not a perfect square. So that means we have two irrational solutions. We can't factor it, and we have to use the quadratic formula or complete the square. Okay. So I told you that if you did what I asked, you would be able to memorize the quadratic formula. And there's actually a song that goes along with it. And if we were still in school, at this point in time, I would make you watch the video, tell you to go home and watch it tonight. And then we would start out class the very next day, kind of screaming this at the top of our lungs. I'd bring in my guitar, we'd play it, we'd sing it together, and everybody would have this memorized. Obviously, we can't quite do that, so I am going to play the song for you. So I'll just have to trust that you rewind the video and you sing it along with this lovely guy here. Here we go.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
As pop goes the weasel.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
So if you know pop goes the weasel, you can sing along with it.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Alright, there's your song. I would play it again, but I can tell my wife is annoyed as she's watching me, so I'd better not. Homework. I'm going to have a Google form. It'll be multiple choice, right? So you'll have to use the discriminant, and you'll have to either select no solution, 1 rational, 2 rational, or 2 irrational. All right? If the discriminant is negative, it's no solution. If the discriminant is 0, it's 1 rational solution. If the discriminant is positive and a perfect square, it's 2 rational solutions. And if the discriminant is positive and not a perfect square, it is 2 irrational solutions. I know that this is super complicated and we went over a lot of stuff today, but I mean, doing the best we can here with it. If you need to ask questions, I know sending me an email is kind of the quick, easy way to do it, but think about it from my end. It's really hard to answer a math question via email. All right, the best thing you can do is go on Zoom and ask a question so I can better explain it and interact. All right, so reach out and come in office hours if you need help. We're almost through this, guys. We got this week and next week, and then we're done. See you guys.